Hello and welcome to How to Maximize Recoveries in Base and Precious Metal Operations through Phased Implementation of Technology. My name is Stephen Johnson, Marketing Manager for Glencore Technology. This is one of two webinars we're running live from Las Vegas as part of MINExpo. We'll cross in a moment to Dr. Stanko Nikolic and we'll begin. Stanko is our Technology Manager for Hydrometallurgy and Pyrometallurgy at Glencore Technology. He has over 13 years experience in the extractive metallurgy industry and has worked in numerous roles in technology, projects, and operations. Just quickly, if you're online, you're welcome to ask questions as the presentation runs. Just use the Q&A icon at the bottom of your screen, and we'll try to answer them online as we go or right after the presentation. And for you in Las Vegas, just raise your hand after the presentation and Scott will be right with you. That's it. I'll give you now to Dr. Stanko Nikolic.
Wonderful. Thanks very much, Stephen, and everyone that's attending online as well as in Las Vegas. It's my pleasure to be able to talk to you today and go through how you can use our technologies here at Glencore Technology to be able to look at maximizing the recovery of your base and precious metals. And so let's jump right in. I think following that introduction from Stephen, we can start moving ahead with the presentation. So really today, what I wanted to take everyone through is taking a look at how we can maximize the recovery to revenue. Now, what we're going to be discussing is recovery of metal values to revenue. This is both base metals and precious metals. And really, we want to be able to broadly look at both of those typical type of flow sheets, because there is a lot of similarities when you start to break down how it is that these ores and concentrates are structured and put through a process flow sheet. So if we look at where most of companies start when they begin their journey of being able to recover to revenue their metal of choice, they're normally mining an overburden or a surface deposit, which is a low-grade oxide deposit, or in the precious metals case, a free milling gold region within their ores. So that then concentrates in the metal values as you go down. But because it's in this weathered oxide mineralization zone, it's all very easy to access. And typically with the standard plant implementation that you can put in, you can get very high recovery to revenue with these plants. Now, where we start to see issues with this is, as if you look at this picture on the left-hand side, you start moving down through the ore body and you start hitting a transition region. And typically these transition regions are where you're going to have a mixed zone of oxides and sulfide mineralization within a particular deposit. And so if you stick to the existing flow sheet, you make no changes, what you're going to see within the results of the operation of your plant is that this recovery is going to start decreasing. And of course, once you get into the deep zone or you want to go underground, that where you hit the primary sulfide mineralization, if you make no changes to your flow sheet, that is where you're not going to be able to make that recovery to revenue that you were seeing at the beginning. So really what today is about is walking through a phased approach to be able to maintain your operation in this green region of the actual graph itself, so that you can then get this recovery to revenue for the metals that you are mining from your deposit itself. So how we're going to be doing that, we're going to be focusing on 3 of our technologies here at Glencore Tech. And this is the Albion process, the Jameson cell, as well as the isomill, and looking at how you would implement these to be able to maintain or attain what is required within the recovery of your flow sheet itself. So before we get into that, I just thought I'd take a brief moment. We've talked about 3 of our technologies. We have 5 in total in our package here at Glencore Technology. The IsoSmelt and the IsoKid are the other ones, and you can look on our YouTube channel to learn more about those technologies. When you look at Glencore Technology as a whole, we are part of the greater Glencore group, over 140 employees in various different regions around the world. And our technologies are spread out throughout the world, and you can see there are over 650 installations. But let's get back to what we're discussing today, which is about how we maximize this recovery to revenue. So let's start at the beginning of the story when we look at this weathered oxide mineralization zone. So the first thing I want to touch on is, well, what is the existing flow sheet or the typical flow sheet that you would put in to be able to recover these metals to revenue? So I've taken two examples here. So for a base metals plant, I've used copper as an example, and for the precious metals plant, I've used gold as the example. So we'll go through the copper example first. Now this this first front end that you see here, primary milling, heap or hollow leach, that probably is very very common when it comes to this sort of oxide region for base metals. So therefore, it doesn't really matter which metal you're chasing. This would be the start of your flow sheet. Where things start to change is in the back end. So when we look at what we're showing here for copper, we've got SXEW circuit to be able to make copper metal. When you look at other base metals, if we look at nickel and cobalt, that is where we may be looking at instead having a precipitation circuit and you making a mixed hydroxide product, which for the nickel and cobalt type of base metals is what you need to make as the feed in to the making battery grade sulfides, for example, or even high purity metals for use in stainless steel production. And so when we look at the base metals flow sheet, really this front end is what we want to focus on, is how do you get these metals into solution for a dedicated back end metal product formation. When we look at the precious metals flow sheet that you see down the bottom here, it's very similar to base metals. You got that primary milling and then you put it through a leaching process. Now, typically, if it's free milling gold, you can put that straight through a CIL plant to be able to then bring that gold into solution. Doesn't have to be cyanide though. You can use whatever is the right reagent for your jurisdiction and for your range. For your location to be able to access that free milling gold. That's really the key thing in terms of being able to bring that gold to market. And really, when we talk about, well, what is it that's going on with these flow sheets? Why is it that as we start moving down this ore body into this transition region, into this primary sulfides, why aren't we able to get this recovery of these base metals to revenue? And that is the key question that we want to look at first, before then understanding how we're going to look at addressing that with our phased implementation of technology. So when we look at why that revenue falls, the main reason is that we're not able to access the actual primary metal sulfides that are located within the concentrates or the ores that we have. Now, those primary metal sulfides for the precious metals case are what is hosting those precious metals. In the base metal case, they're the ones that we want to get access to be able to bring that into solution. So when we look at what is actually happening, what's preventing us once we start seeing these sulfides from accessing these metals that we need to get to, it is a process that is very well understood in the hydrometallurgical world, and that is passivation. So if you think about it, this on the left-hand side here is what we see as the ore or the concentrate that's coming into our process. We've got those sulfides freshly liberated and those fresh surfaces coming into that next part of the process. But when we start putting it through a leaching process or trying to access those metals, then what ends up happening is a small 2 to 3 micron thick surface layer starts to form, and that blocks our access to these sulfides or blocks the access to the precious metals, process known as passivation, and therefore it stops us from being able to bring these things into solution or access the precious metals, and lowers our revenue because we're not able to access this. Now, when we reflect on what's actually happening here, and we consider that this is a sulfide that has the metals in there now instead of an oxide, or the precious metals are hosted in this sulfide, our first step is going to be to do what everyone within the industry would do as their first step when it comes to trying to recover revenue from sulfides. And that is actually looking at putting in a flotation process and separating those sulfides out. And so when we look at what is the best way for us to do that, that is to put in a Jameson concentrator. So in a couple of hours' time, we're going to have my colleague, Len Stiper, present to you about the Jameson concentrator and take you through this real new breakthrough initiative that we've been spearheading within the industry. If you're not able to make the presentation, the next one that's coming up, then please go to our YouTube channel. We actually have a couple of videos from some of the operations, Hud Bay, where we interview them about discussing this technology and why they're implementing it on their site. We also have a run through of it applied to one of the new projects that we're going to be commissioning next year. So take a look at the Jameson concentrator, but really today what we want to look at is, well, okay, you're going to do this phased implementation. You're going to put in the Jameson concentrator. What is it that you're going to do to be able to recover the valuable metals to revenue? It is actually producing a saleable concentrate. That is the main thing that many sites actually do. They look at, okay, the sulfides are there, let's recover into a separate phase, sell them to market, get our return on capital. If we have any metal values left in the oxides, that's going to go through our existing process, which would be existing on this side. If we've exhausted those oxides, or it's not economic to treat them anymore, then we're going to be producing tailings, which would be then stored on site. So the key aspect here with this phased implementation of putting in the Jameson concentrator is that by selling this concentrate, we don't actually get that full value or full recovery to revenue. It's going to drop the more sulfides are actually going to be present within our feed. And the real reason behind that is that we're passing on that material for someone else to treat. We've got to pay treatment charges. We've got to pay refining charges. We've got to pay for someone to be able to recover the metal values and make the final metal product. So many sites, this is the first step that they look at. But what I want to touch on is, well, why would you look at having to take a further step and look at a further implementation technology to look at making final metal products or intermediate products again within your operation? And so why is it that you get driven down this path, or why should you actually consider to be driven down this path? And really, this is a key question to answer, not only for existing operations, but also for new ones. Once you've exhausted that initial deposit, you want to look at how, and I'm making a concentrate, can I sell that concentrate? Can I sell that concentrate for good terms? So really what I want to touch on next is 3 reasons that you may want to look at producing a metal product or taking it further from just the Jameson concentrator implementation for your site. So the first reason that you may do something different in terms of just producing a concentrate is that the local jurisdiction or the tax law within your region of the world, or even the social license that you have, means that you must make a final product. And this is something that we touch on with many jurisdictions around the world, where when it comes to making a concentrate, that's something that's doable, but they aren't able to sell that concentrate for good terms, or that the government puts on a huge tax load on that concentrate if it's sold as an intermediate product. So this is probably the first reason that we look at as to why someone would then not want to, well, would want to proceed further past the implementation of a Jameson concentrator. If we look at the second reason that we have that we want to touch on today, it is all about, do you have a complex concentrate? So what do I mean by that? Now, what I've shown up here on the screen on the right-hand side is taken from Wood Mackenzie, and it is from a report they did earlier this year, where they looked at typical penalty limits and charges for a copper concentrate that's traded around the world. So there's a couple of things that I'll bring your attention to, but one of the key things to do with a complex concentrate, that means that you might have zinc in your concentrate. You might have nickel, you might have cobalt, you might have various other precious metals, bismuth in there, which is a valuable element in its own self. So when you look at these penalty limits that you see here, let's touch on nickel and cobalt first. You can see here there's a limit of 0.5%. And so that then means that up to 0.5%, your actual customer doesn't pay you any money for your nickel and cobalt. But if you've got more than 0.5%, what actually this means is that you've got to pay your purchaser of your concentrate. You've got to take a hit for this concentrate for adding these nickel and cobalt credits in, to be able to have that person treated. So that means, one, you're selling a concentrate, you're not getting the full value of the copper, and then two, you're actually having to pay that person to take on these other base metals and turn them into a final metal product. And that then means that if you have a very complex concentrate, if we take zinc, for example, 3% is the limit here. So if you got more than 3% zinc, you are paying that end customer that's taking your concentrate a fee, so that you're lowering your revenue even further for taking this material. And so what that means is that if you got a complex concentrate, you're going to be making even less money than what it would be if you were then processing this material into the separate metal products and then being able to get the full value of those metal products. So this is the reason that a lot of clients come to us. They're like, look, we got this complex con. We cannot get good terms. We're actually having to pay penalties for things that are worth a lot of money. If you look at the price of nickel and cobalt compared to copper, you're going to start asking these questions as to, is this the right outcome for my concentrate? Now, the third reason that we talk to clients as to why should they look at processing their concentrate further is if it's a high impurity concentrate. So what I've taken here is, again, a report done by Wood Mackenzie earlier this year, where they looked at the import concentrate limits for one of the bulk smelting hubs of the world, in this case, China. And really what this means is that if your concentrate has more than 6% lead, has got more than 0.5% arsenic, you will not actually be able to get this concentrate into country for treatment. It will be rejected and sent back to your site, and you'll have to pay all of those costs. And therefore, this is one of the key reasons clients come to us as well, especially in the precious metals space, when it comes to, hey, I've got an arsenopyrite portion within my gold con. Is that going to be a problem for me? At the moment, we would say, well, what is your arsenic? Now, the other thing to bear in mind is these limits are changing, and they're not going to be going up. Those limits or rejection limits are going to be becoming tighter and tighter. So then you really need to question, is this the right process outcome for my concentrate, or should I be looking at implementing a solution on site to be able to extract these metal values? So really, when we come to how do we look at doing this, we have to answer that question that we touched on at the beginning. How do we overcome passivation? Because if we want to process this at our site, if we want to be able to extract these metal values, how is it that we're going to overcome this? So what I'm going to do is look at the two cases. How do we overcome it with base metals, and then how we overcome it with precious metals? We're going to go through a few flow sheets and then talk about some of the results that we've seen with Albion plants around the world running within running with overcoming this passivation problem. So when we consider what we do in the Albion process, it's a very simple solution that we have to passivation, is that we take these larger particles, even though 70 micron is quite fine in the flotation world, and we want to grind them even finer. We want to ultra fine grind through our isomill technology. And so here we're taking it to this between 10 to 20 micron size fraction to be able to really then liberate all of those minerals that were base metals that we're trying to access. And really, by grinding this fine and putting them through the isomill, we're doing two things. The first thing is the isomill produces a very fine particle size distribution. This is all about how the isomill works with its internal classifier. It's able to produce this very narrow size distribution. And the other thing is the grinding mechanism of the isomill produces micro cracks throughout the structure of the minerals themselves. And that then means that when we put it through a leaching process or oxidative leaching, this is where we're able to then fully access these base metals and then not actually have to worry about passivation, because it's not able to form to a sufficient level to be able to impede the kinetics of leaching. So if you want to think about it, how do we overcome passivation? It is all about us being able to ignore passivation completely. Look at other technologies, they may do it through elevated temperatures and pressures, or through biological agents, very complicated systems and reactors. What we do in the Albion process is fine grinding and then oxidative leaching, atmospheric conditions, very, very simple, easy to run process for us to be able to then look at accessing these base metals that we have. So very applicable to copper, cobalt, zinc, nickel. And when we look at, well, what happens to the precious metals, what happens to acid insoluble elements like tin, lead, moly, well, they'll be left in the residue, and then we can actually target them through specialized flow sheets within your system as well. So that if that's a part of your ore, we can look at recovering that or turning it into an intermediate that could be used for sale to another facility. So let's take a look at how you would actually implement this on your site. So I'm going to reflect back into that flow sheet we looked at earlier, and I'm going to be using copper as the example. Again, if you're looking at nickel and cobalt or zinc, you may swap out this SXEW for a precipitation circuit to make these mixed hydroxide products. So really, when it comes to the back end, it's technology, it's agnostic in terms of what we're doing when it comes to the Albion process. We really want to be looking at how do we get these metals into solution and how are we going to do this phased implementation. So of course, the first phase, we touched on it at the beginning, put in that Jameson concentrator. If you can make a concentrate to be able to recover your economic values, then that's what you will be doing. That's what you should be doing. When it comes to us looking at the next step in terms of, well, how would we phase this approach? It's going to be, well, is selling a concentrate viable for you? Or do we want to actually reutilize all of this old infrastructure? Of course, if you just make a con, you're going to have all of this infrastructure that's out here in your actual plant itself, unused, sitting there, perhaps some care and maintenance. When we look at what the Albion process lets you do, it lets you actually reutilize all your existing infrastructure on the site itself. So when we look at the base metal example, we take this flotation concentrate from the Jameson concentrator. We're going to put that through the isomill to do the ultrafine grinding. We're going to put that through the oxidative leaching. That you see within that boundary there, those two things together, that is the Albion process. That is the core of what we do. After we've brought these base metals into solution, we normally go through a neutralization step. Typically, this is to remove the iron from the circuit so that we can then bring in our base metal rich solution into our extraction system so that we can make the product that we are actually chasing. So that is the key part to the Albion implementation in this base metals space. So let's take a look at an example of where we've done this. This is a plant within Zambia producing 100,000 tons per annum of copper cathode. Of course, this was considering a smaller installation, and that's something that's really, really beneficial to the Albion. We can work with you no matter the tonnage of base metal you're making. It could be this 10,000 tons. It could be 300,000 tons per annum. It could be even more. This is something that we can work with and is not an impediment in terms of being able to understand how you can implement the technology. We've got smaller reactors. We've got ones that are many, many tens of meters in diameter as well, applied to different ores and tonnage rates through systems. But when we look at this particular example, the thing that I like about this is that this site had put their CCD circuit SXEW on care and maintenance. And in this jurisdiction, they were not able to sell a concentrate. So they were looking at placing it within the actual smelting hubs of that country, but they weren't able to get good terms. And that's where we came in, and we then converted a couple of the leaching tanks they had within their existing circuit to be Albion process leach reactors. We put in a hypersparge system which drives the oxidation kinetics of the actual process itself, and we're able to then put in the copper rich liquor into the SXEW circuit to be able to produce metal. And when you look at what the design outcomes or the operational outcomes from the design of this plant were, we were treating a head grade of about this 29 to 31%, actually quite a varied copper mineralogy, mainly chalcopyrite, but we had some secondary sulfides in there as well. And we're able to attain over 98.5% recovery within the circuit. As you can see, commissioning late 2017, within the first few months of commissioning, we were operating at the design level or then in excess of the design level that you see here in the black line. And this was a successful plant. This was the first batch of copper cathodes that were produced from the plant and being sent to market externally. So real success story in terms of implementing the Albion process on a site. So let's touch on next the precious metal side of the flow sheet. How does this quite work? And really, how do we bring these values back into recoveries revenue into that green region? The first thing we're to look at is how do we overcome the passivation in precious metals? So very, very similar to the base metals. I've just changed the little pictures here to white to reflect that you're not maybe having copper minerals. You're mainly going to be having arsenopyrite or pyrite type minerals that are hosting your gold within these circuits. Not to say that's the only ones. We've dealt with many different gold hosted sulfides and been able to extract them. Now in this case, it's a little bit different how we're applying the Albion process. The first part of it, ultra-fine grinding, preventing passivation by ultra-fine grinding and accessing those sulfides is exactly the same as base metals. But what we're leaching into solution is the actual iron, arsenic, or the gold-bearing minerals. So that's what leaches into solution and then actually liberates the gold. So that then is free and becomes the equivalent of your free milling gold in your weathered oxide ore. So then you can actually take that material and put it in your standard CIL circuit. So when someone asks us, does the Albion process make gold? The answer is no. The Albion process liberates your gold so you can put it through your existing infrastructure and your existing flow sheet. So that's how the Albion process for gold works in terms of being able to do the ultra-fine grinding followed by the oxidative leaching. So when we look at the staged implementation within this precious metal space, again, we're going to use gold as the example. This is one that's allows us to have an additional phased implementation point for our technologies. So of course, first point, Jameson concentrator, make that con, sell it if that is then going to be able to be the profitable outcome or the return on investment that you have for your plant. And that'll be your first step. But when it comes to the second step, we don't need to implement the full Albion process to begin with. And the reason is, if you look at what the Albion process is doing for gold, it is liberating that gold through oxidative leaching of the gold hosting minerals. So actually what you can also do to liberate gold is through size reduction. And that is through just putting in the stage implementation of the isomil ultrafine grinding. So what we find when we do the test work for our clients in the Albion space, we look at first, what is your gold recovery of the as received mineral concentrate or ore, and then we look at what is the gold recovery through just ultrafine grinding. Is that enough to be able to then access the gold within your ore and be able to produce that metal product? So if we look at this example here, where we've got ultrafine grinding pre-CIL leach, we've got over 20 of examples of that within industry where we've got these isomils located doing this duty. So this is actually the next step after putting in the Jameson concentrator that we would help you look at implementing on your site to be able to access this gold and putting it through your existing process. Now, in some cases, it depends on the gold mineralization or how it's hosted or a number of other factors. Just ultrafine grinding isn't enough. And that's where we need to put in the full Albion implementation, where we're going to be doing the oxidative leaching to liberate and free up that gold and put it through your existing process. Now, before we go on, I will touch on an alternative to this flow sheet, which is then focusing on the tailings. So it could be that you've been running for many, many years and you've been putting these gold-hosted sulfides in your tailings deposit. And your question to us would be, can you do something about this? Of course, the answer to that question is yes. First thing we'd be looking at doing is making that con, but then really what we want to be doing next is that first implementation. Does putting it through ultrafine grinding give you that outcome of being able to access that gold back in your CIL plant, bring it to market? So we do that first. And then if that isn't enough to be able to provide the gold uplift you need, then we look at the full Albion process implementation to be able to liberate that gold. Now, of course, we can do a combination of this flow sheet and the previous one. We'll put in a dedicated Jameson concentrator for your tailings. We can put in a dedicated Jameson concentrator for your feed as well. And in that way, have the Albion treat the products of both of those streams. And then you can make sure that you can really access all of that gold that's coming to market. It can really simplify the actual infrastructure if you separate those two streams in terms of floating tailings and floating feed. And so then you can make sure you access any other liberated gold that's in the oxide from the upfront flotation back in your existing CIL plant. So really a couple of options here that we can work through with you to look at what is the right way to implement the Albion process for your site. Now, what I wanted to touch on next is an implementation of the Albion process in this precious metals. So the operation I'll touch on is GeoPro Mining, which is located in Armenia. There, they're producing 120,000 ounces of gold per annum. When we look at what we're involved in here, it was installing the isomill, installing the oxygen plant, installing the limestone plant that's used to drive the kinetics of the leaching, and also then the installation of the Albion leaching circuit that you see there on the top right-hand side. Now, we also help this client upgrade their concentrator to be able to make sure that we were able to put in the right sort of, we'll minimize the capex of our Albion plant, treating this material coming through the actual plant itself. So when we look at the actual process itself or the outcomes from when we did the commissioning, so this is in months, sorry for missing off the scale down the bottom there, but this is in months from commissioning. And you can see this is the monthly variability that we have. So here on the bottom, this orange line, you'll see this is the sulfur grade. You can see here variability from about 5% all the way up to 40% sulfur coming through this Albion process. So these are the sulfides that we need to oxidize to be able to liberate that gold and put it through the subsequent gold recovery process. When we look at what the Albion was able to achieve in terms of oxidizing those sulfides and maintaining the grade, you can see here the design recovery, 92%. We're able to maintain that gold recovery in that 95+% mark for using the Albion process in this case. This is one of the key differences of Albion compared to other oxidative leaching technologies is the ability to deal with variation. It's all to do with the simple ultrafine grinding oxidative leaching step. We're not having to do any more complex management of sulfides or of what's coming into a pressure vessel. It's a very simple plant implementation and allows us to deal with this variability. But what I wanted to touch on next for you, and this should hopefully work quite well. It may not be a video for you, but it will hopefully be a series of stills as this video plays, is to take you through a look at the actual GeoPro Mining Albion process plant in Armenia so that you can actually see what this Albion process looks like in reality for the actual plant implementation itself. So what we're going to be looking at taking you through is the full plan implementation. You can see here in this first slide, that is the M5000 that's there, the isomill that's doing the ultra fine grinding, that's producing that narrow particle size distribution with the fine cracks within it, that is feeding into the Albion leach train, which we're now panning towards, as you can see here. So these are the Albion leach train that we have that is then performing the oxidative leaching of the actual concentrate that's put through this plant. Now you can see as we go down the line, we can start seeing steam being generated through this process. What's actually happening here is as we're doing the oxidative leaching, now we're going to be looking vertically down at the actual tanks themselves. As we're doing this oxidative leaching at the base of those reactors, we have our hypersparge system, which is driving the oxygen in there, oxidizing those sulfides, and then being able to generate heat within this process. And as we move down the train, we're using this heat to drive the kinetics, and we're getting closer and closer to the 95+ degrees Celsius in terms of an operating temperature. And of course, being atmospheric leaching, autothermal, we're then able to then operate with this steam coming out and being able to then make sure that we take advantage of kinetics. Now, what you see on the left-hand side there in the foreground is the oxygen plant, one of two that they've got installed there. In the background, you'll see there on the left-hand side, that is the existing CIL circuit that the client had on site, that this Albion product that we've got, this oxidative leach product, is going towards to recover the actual gold values themselves. And this gives you a nice overview of the whole installation itself, looking at the concentrator and all the other aspects. This is a really nice view showing the reactors themselves. And yeah, so at the base of those, that's where we've got the hypos pipes. That's where we have the magic happening in terms of driving the reactions with this process itself. So I really hope that gave you a bit of a taste of what the Albion process looks like. What is it that's there in terms of the actual reaction and process itself. So the next step, or the next question that you may have, is we've talked through a lot about how the Albion will be useful to you as a site. And your next question is going to be, well, how do I implement this? How do I see, does the Albion process actually give me a benefit? So what I want to take you through is then what is our approach to be able to bring clients through the Albion process story, or the phased implementation of the Albion process for your plant. So we do this through 4 distinct phases in terms of our programs. Our first phase is what we look at as our fast fail test. So really small sample, short duration. We're going to be able to then look at what is the uplift that's provided. We can do the flotation test work as well to be able to size the Jameson concentrator at this stage as well, and give you the CapEx and OpEx of that side. But we then look at, well, this is the uplift that's provided by the Albion. This is how much the Albion will be costing you as an operation. If we look at the precious metals case, we'll also look at, this is the cost to just the isomill as well as the full Albion, to be able to then look at how that is implemented in your circuit. And you can then make a decision quickly as to whether we need, do we go forward and look at creating a larger sample, doing more test work, and look at taking this down the process of execution of an Albion at your site. When we look at that phase 2 program, this is where we do the variability associated with your mine plan. We also do the isomill signature plot that allows us to really size the isomill for your specific ore, and that requires a much larger sample. We're talking about now 20 kilograms of sample needed, and it is a longer duration for the program. At this point, we can do a pre-feas or a fees level study, or what would be known in the AAC guidelines as the class 4 or class 3 CapEx OpEx study, that we can then work in with your financial requirements in terms of approvals for your system to be able to then push this project to the next step. When we come to, okay, the project is viable, we want to go ahead, what is the next step? A lot of clients will say to us, do we need to do pilot plant test work? From our perspective at Glencore Technology, we would have done everything we needed to do in phase 2 to be able to give you our process guarantees. From our perspective, pilot plant test work is not required, but we do have worked with many companies where this is required from their side, from their actual capital framework systems, that a pilot plant program is required. And so therefore, this is something that we've helped them do either on their sites or that we've done in one of our laboratories that we use for the Albion process. At this point, we do a class 2 study. This is where we do the plus or minus 10%, and that then leads into the technology supply and execution phase of the project itself. And when we look at where do we do this test work, we've got 3 certified labs. We've got Core Resources in Brisbane, we've got SGS Lakefield in Canada, and we've got the Tom's Institute in Russia. So these are the 3 certified labs. When you come to us, we will look at which is the right lab for your location to be able to then process this material. And of course, we also have our partner at GPM, which we can then look at getting you to that site and visiting and understanding more about that technology. And also when it comes to implementing the Albion process, going there for training in actually running the Albion process itself. So at this point, I'll stop the presentation, or we'll open up for questions from the audience. But really, if you want to have a real think about everything that we've discussed today, if you want to take a couple of the points and talk about it with your teams, please reach out to us at albionprocess@glencore.com.au for any of your further questions. And really, the other place that you can find more information is our YouTube channel. We've got a couple of more dedicated presentations for base and for precious metals up there. But of course, please feel free to ask your questions now. I think I see there's two in the Q&A and a couple of people with their hands up. So then I might pass over to the team with Stephen and also Scott in the room in Las Vegas first to share this next bit. And I'll look at answering some of these questions for you in the intro.
Thank you, Stanko. That was great. Yes, we will take a couple of questions. I was about to ask Juan to lower the hand and to put some questions in, so he's done that. That's great. And Scott may have a couple of questions from the room too, so we'll give everybody a chance to ask questions. Stanko, I will kick off with one I've seen down here. I've seen your IsaMill and Jameson Cell have online calculators. Before the phase 1 program, is there any way to obtain a basic amenability of Albion process to our operation? Stanko.
Yes, definitely there is. We are in the process of creating and then uploading the Albion process calculator. So that's something that you'll see within the next six months loaded and put on our system. So we want to make this as easy as possible for you to implement on your site. So, but at the moment, when we look at what we will be doing in the interim, is please reach out to us and we can then do a quick assessment. We have a data sheet that we'll ask you to fill in, and we can do a quick assessment on the amenability of the Albion process, and even do, in some cases, a quick CapEx and OpEx based on the information that you give us. It is very high level. It wouldn't be in terms of something that we would anchor to AAC guidelines that you could use for costing. We would have to then take to that phase 1 approach to get there, but we can actually then look at answering some of those particular components and being able to give you that indication. Now, the online calculators for the Jameson, so I see a question there, where are the online calculators? So that's something that I think we'll provide at the end of today. But if you go to glencoretechnology.com.au, you can then go to our websites for the IsaMill and for the Jameson cell, and there you will find the links to the online calculators. Also, if you follow us on the LinkedIn page, there's a couple of links there that you can follow that'll take you to the online calculators for the IsaMill and for the Jameson cell, and the application to your actual site itself. So if I look at some of the questions online, I might answer those first, and then we might cross to Scott in the room and see if there's questions there.
Thanks,
so the first question here from Juan Anes, I hope I'm saying that correctly, is what is the scale-up factor for lab Jameson float and for the Albion lab test? So that's a very good question. Thank you for that one. When we look at the lab Jameson flotation test, that's something we can actually design the Jameson cell off something, even off a Denver cell. So we have a special procedure that we provide to the laboratories, even to clients, which we call our 3-stage dilution cleaning test using the Denver cell. That in itself gives us enough information to be able to size the Jameson concentrator for your particular site. Or if you're just looking at a Jameson cell for a particular application in your plant, then that's enough for us to size the Jameson cell for your actual site itself. When it comes to the Albion process, what we do in the lab test, so these are, I guess, smaller scale. As you tell, the first one is a kilogram scale. Even the variability, there are bench scale tests that we're doing, and we get all of the parameters that we need to design the full scale plant from that. As I mentioned, all of our process guarantees are able to be then met with that test work that we do in the laboratory scale. So that's how we've done the majority of our plants, is from that process. We understand the Albion process scale up very, very well to be able to then provide those process guarantees so that you know that you're going to be getting the actual outcome that you need from your technology implementation at your site. So for us, the scale up factor there would be very large, I would say, if you go from the bench to the full scale. But that's something that we then understand from all of the Albion plants that we've done across the world. So I see there's another question here from Han as well, which he's asked, is XPS in Sudbury a certified lab for the Jameson and Albion? So XPS in Sudbury do have a laboratory for the Jameson cell. I believe they also have an ISOMIL, so they'll be able to take you through that part of the test work. At the moment, they are not one of the certified labs for the Albion process. They actually send their samples that are being done for the Albion process to SGS Lakefield in Canada. So the XPS group haven't specialized in the Albion area. Saying that, they do have the facilities to be able to look at various other flow sheet arrangements within the hydromet space. And then that's actually something that we can help you with as well in terms of being able to provide the information you need to answer the actual questions for your capital framework or for your requirements for your studies. Now I see Juan's asked another question, but maybe we'll cross to the room first.
Yes, I think there are a couple of people in the room who have some questions too.
Yep.
If we could go to Scott, please. Thanks, Stanko. Thank you very much.
So do you guys just want to know if you can get a copy of the presentation?
Yes, so we can discuss it back in Mexico with our technical guys.
So
then we can have some direct questions to send over.
Stanko, there's some gentlemen from a Mexican operation and they would like a copy of the presentation if possible.
Yes, of course, that won't be an issue.
Okay, so I'll get their email and then, and if you have another question.
I got one question.
Sorry, that one doesn't wire in here, so just come here. Yep. Yep.
May I get in?
Yeah, you can come, yeah.
I would like to know if your operation at Las Lagunas, Dominican Republic, I understand that you have this equipment, this plant working for several years. I would like to know if you have still this plant is running, or you are planning to move that plant or the mining company is planning to move this plant to Cuba or stay there at Dominican.
No, that's a very good question. So Las Lagunas is one of the first implementations for Albion for gold. Their implementation was treating the tailings. So if you think about that's the second flow sheet that we looked at as to how you would extract the precious metals value for using the Albion process. And because they were treating a tailings deposit, they did actually exhaust that deposit in 2019. So the Albion process plant that's located at Las Lagunas has been on care and maintenance since 2019 because they recovered all the gold that was there on site. Now we have discussed with that client, the company that owns Las Lagunas, in terms of being able to make the Albion infrastructure available for other clients in terms of them being able to purchase that. They have been open to that. We did get to late stage negotiations with a client about a year and a half ago, but that didn't go through at that point in time. But yes, that equipment is then available. Las Lagunas is actually looking at using it as, or considering, or there's a couple of options that they're looking at there to use it as a bit of a hub. So it'll become an Albion process hub in the world where they'd be able to treat these refractory concentrates. So they are evaluating that opportunity as well against selling the infrastructure that we have on the plant itself. So yes, those are the options, but I really see it as a success story for the implementation of the Albion, that we're able to process all the gold that was located at that site. So thank you very much for the question.
Thank you. I gotta, well, let me introduce myself. It's, we are from Mexico. We have a mining operation just acquired one year ago. This mine is a polymetallic mine with a refractory mineral. We are going through for the gold, silver, lead, and zinc and we have 1 million, almost 1.5 million tons of tailings with good values that we would like to recover. But we don't know if, since this is a refractory mineral, we would like to know if this process would be for 1.5 million tons for those tailings would be economically feasible, or if we should look for someone that already has the equipment and the plant that could handle our tailings.
No, look, definitely, I think that's something that we can help you with at Glencore Technology. So we'll be able to provide you that initial assessment in terms of the CapEx and the OpEx for your plant. So you can have that question answered for your board. This is the cost for us to be able to implement this at our site. We can then try and provide you a look at when it comes to the use of other equipment that then is available, be it at Las Lagunas or another site. And then we may be able to assist with our trading arm in terms of placing your concentrate in different parts of the world as well. But of course, it all depends on the terms, and complex concentrates, it can sometimes be difficult to get good terms for those concentrates, as you would be finding. And so that's something we can help you work through. Definitely when it comes to base metals, so we've dealt with zinc and lead, materials, putting that through the Albion process. We have a few plants in Europe as well as Australia, and we definitely have the expertise to assist you there. That's for sure.
Scott, if there aren't any more questions there, perhaps we could go to Mosen's question online. Would that be okay?
No, yes, of course. No, I can see that one. Thank you, Mosen. I see your question here. Is for those in the room that may not be able to see it, is does high altitude affect the Albion process? For instance, the need for more oxygen or other effects? So that's a great question. When we look at what the impact of high altitude is, the fact that we have there is that the lower pressure, the lower atmospheric pressure, the lower boiling points of water as well. So normally what we see there is an impact on kinetics that you may have. So then that's something we work through in the actual testing phase. That then may mean that we have an increased size of reactor, or we might have an additional reactor at the end. That is one of the real advantages of Albion, is the modularity of our oxidative leach reactors. We can then look at adding additional reactors if you want to increase the tonnage of your plants at a later date. But when we look at the other effects, so the way we are adding oxygen into the Albion process is through oxygen sparging at the base. Now that then means you have this head of liquid that's above those oxygen sparges. And so if you are then at high altitude, you will need to spend more OpEx when it comes to pressurizing the oxygen to be able to deal with that hydrostatic head of water. So that is then another impact in terms of high altitude when applying the Albion process, is the OpEx will be higher for compressing that oxygen. We don't see there being an impact on the actual oxygen utilization, but we do sometimes see that there could be an impact on the kinetics due to the lower temperature that the water is boiling. So I hope that answers your question, Machine, but please, if you want to have a few more details, our technical team will be able to follow up with you after the call.
Thanks, Stanko. Juan has a question there regarding
yes,
but I might suggest that we let Glenn answer that later. Juan, if you're going to be participating in the very next webinar, that would probably be ideal, and Glenn would be able to cover that off for you quite well. But there is a question there, another question there, Stanko, regarding the training. If you'd like to
yes,
that, please.
Yep.
Thank you.
Wonderful. So the question is, do you provide specialized training to people that don't have the Jameson cell and the Albion technology? So the answer to that is yes, we do. We have technology transfer program that we implement with all of our technologies. So with the Jameson technology, then that is something that we would be able to have your people come to a site to visit, to understand the operation of the Jameson cell, and one that's applicable to your actual flow sheet. And then when it comes to actually operating the plant, we have training programs, as well as then we can either, during these COVID times, we've been doing our commissionings remotely, where we can send a headset to your site that then allows your people to be wearing that with a hard hat, and then our teams can remote log in and then assist you with the commissioning of that plant. That's been very, very successful during this COVID period, to allow us to keep implementing our technology around the world. When it comes to the Albion process, this is where we have typically sent the people to one of our operating sites. So for the gold space, that would be sending them to geopro mining in Armenia. So we then organize these training programs. We would have all of the, you would send your actual operations people there to be able to then look at understanding how you operate that process. And when we look at like a good example of this being applied is actually the geopro mining site in Armenia itself. So this plant was built in a region where there was no heavy industry, and the local population were, you know, in terms of being not very many skilled workers, more in the sort of agricultural type space. And so we put them through our training programs at the Albion sites, as well as having our people come to sites and put them through training programs that were dedicated at that facility as well. And then that allowed that fast ramp up. I mean, the Albion process has got close to McNulty Class 1 ramp up, close to 80% production within the first 12 months, and bordering on that almost 100% design within that first 12 months or shortly thereafter. And that's something that we're very proud of here at Glencore Technology, the ability of our plants to perform to the levels that we have designed them to for our clients, and is part of why we're so confident in our process guarantees that we provide to our sites.
Thank you, Stanko. I don't think we have any more questions right now. So it's probably, I'll just give Scott a last chance there in case there is anything from the room, and then we'd probably close. Scott, any last questions? I don't think so. All right, Stanko, many, many thank yous for the presentation and the time. And thank you everyone for attending online or live from Las Vegas. We will close the webinar now. If you've asked a question and it hasn't quite been answered yet, it's okay. We'll be answering all questions later and sending you the answers. If you're there in Las Vegas, please feel free to stay a moment to talk with Scott. If you've joined us online, thank you very much, and we'll see you again soon. Thank you and good night.
Thanks very much, everyone.